Hello everyone, welcome back. So in this video we're going to be learning about something called the split, apply, and combine method. So the context is this. It's really common if you're working with data to want to ask questions like, what's the average Coleman length of penguins living on this island? Or does the average Coleman depth differ from one species to another? In other words, it's a fundamental task to try to summarize your data by group. And so we typically split this step up into three frameworks called split, apply, combine. This was developed by Hadley Wickham. So first, we split the data frame into groups, say one for each species of penguin. Then we aggregate, we apply an aggregation function, perhaps the mean over each species or the average length of each species. And then we combine all of this into a single nice, pretty looking data frame at the end. Split, apply, combine. It's an elegant idea, and it's also a very powerful idea. And it's actually quite easy to do in Python if we use the pre-written functions of pandas. And the reason for this is that people had applications like this in mind when they raised the panda bears, i.e. when they wrote the code for the panda module. So before we get started, I'm going to run exactly the same pre-processing as last time. And what we're going to do is we're going to import pandas as PD, numpy as npy, read in the penguins using pd.readcsv. We're going to restrict attention to certain columns specified by this list here. We pre-process the name of the species to make it easier to read using the methods of the string class, which are behind the string wrapper. So it's species.stro.split to split it. And then to get the first element, we do .stro.get. We also made new columns called length and depth, which are the same as Coleman length and Coleman depth in millimeters, easier to work with though. And then we use the drop of a list of columns, labels equals the list we're dropping, axis equals 1, lets the dropper know to drop columns, not rows. And now we look at this beautiful data. So that's our pre-processing, exactly the same as last time. I'm not going to force you to type it again, but I did want to go over it briefly to reinforce your guys' learnings. All right. So if we want to group a penguin by species, we just type in penguins.group by species. All right. Now this tells us that it's a generic data frame group by object. So we did it right, but so far this is not particularly useful. So we want to get something useful. We want to get the average of each species. So we just type the exact same thing in as before, but then we type in .mean. Penguins.groupby.species.mean. Now we have this beautiful data frame where we've done the split, apply, and combine all in one. The thing about pandas is these pre-written functions let us do very powerful things all in one step. We grouped by species, then we applied the mean, and then we've summarized this in a single table. So we can see that the average length of chinstrap penguins is much, much longer than for Adelie penguins, for instance. Now, sometimes we don't want all the columns. Maybe we would just want one of the columns. Maybe we just want the length column. So here, this is where we need to add in length. And we do need to be just a little bit careful, because if we just add in length by itself, it's going to give us a data series rather than a data frame. So we need to add in length in double quotes, or double brackets, sorry. Don't forget the quotes. And now it's going to give us the mean applied just to the length column. We use the double brackets to make sure that it's a list of columns that we're aggregating rather than just the name of a single column. Now we can also get multiple summary statistics all together. And for this we do penguins.groupby species with a capital S. And now here we have to use the aggregate method. So we type in dot aggregate. Aggregate is our general term for mixing things together and summarizing the whole group. And now we need to say what aggregation functions we're going to use. We're going to use more than one of them, so we're going to create a list. And then we need to name the functions. And now here's a very common pitfall, is you do not put any parentheses here. So you just type an np.mean. Because we want to name that we're using the mean function associated to the NumPy module. We don't want to actually call it. So we do all of this, and now we got this awesome looking table. We got length over here, we got depth over here. For each length and the depth, we got the mean and the standard deviation, and then we split it up into all of these species. Perfect. Now we can also group by multiple columns at the same time. And here this is just a little bit tricky, but what we do is we say summary is equal to penguins group by. And now we don't just type in species like we did before. We type in a list of columns. So we have in species. Let's group by species and by island. And then the rest is the same as before. So we're going to apply several aggregation functions. So we type in dot aggregate. And then we list out our functions. np.mean, np.std. For some reason, I can never remember that there's an n in penguins. But let's take a nice look at our summary table. Alrighty. We now have this beautiful table. Something to note is that chinstrap penguins can only be found on the Dream Island. Gen 2 penguins are actually only found on the Bisco Island. That's why there's not as many like multiple layers there. But Adelie penguins, they're all over the place. They're on all of the islands. So when you have this kind of hierarchical table like this, it's a little bit tricky to try to focus in on just a single entry. So to do this, let's try to focus on just grabbing this number here of the 38.5. So what we're going to do is we're going to first restrict to Adelie Dream. So we type in Adelie Dream is equal to summary.loc. And we have to type this in an Adelie and Dream. Let's take a look at what we get here. And something was misspelled. I forgot the quotes here. All right, so now we can say that this entry here is going to have the length and the mean, all the information just associated to penguins with type species and island Dream. Now to just extract the mean and mean of the length column, we do Adelie Dream dot loc length mean. And we're going to get the number, which is the average length for the Adelie Dream column, 38.5. Scroll back up. We see we're able to get this. So the group by function is very powerful. It lets you split up your data in meaningful ways, and you can create really cool tables. And this is really very powerful. So that's it for today. I'm going to stop here. I will see you again next time.